Okay guys, so today exponential functions, we're going to get into, like I said, all about them and what they look like today, and then we will actually graph them starting tomorrow. So this is part one of the set of notes. We break it into two just to make it a little easier to absorb this. This is basically the concept today, the formula, what it looks like, tables, and then tomorrow we'll actually use those tables to graph with. So getting started guys, this is what an exponential function looks like. Exponential functions are going to be in the formula, like the way they look is y equals a times b to the x. Okay, let's just remember, just going back, we already have one function that's going to be here. What's the form of a line, a linear equation? Linear looks like what? Y equals what? There we go, mx plus b. This is linear. I might write that down because you're going to need to answer questions about that in a minute. Might want to get that down. Just to remind you, doesn't hurt. Exponential looks like this. Y equals a times b to the x. Now guys, listen, people get panicky over the a and the b. The a is the plus or minus. That's all it is. Is it positive or is it negative? Okay, listen to me. The a represents the positive sign or the negative sign. That's all it represents. So if A is positive, then your graph is going to go up. It's not that complicated. Look at the two that have positive numbers in front of them, right here, the red ones. See how both the positive ones go up from the outside up, from the outside up. Okay? If A is positive, the graph goes up. So take a wild guess. If A is negative, where's the graph going to go? And which ones are those in the picture? The negatives, which are the blue ones. Yes, look right here. See the negative number on these? Negative ones go down. So they start there in the middle and they're going to go down. This one goes down. They both start and then go down. Start from here, go down. Okay? Now, the other number decides whether it's going to go to the left or to the right. Okay? To the left or to the right. Look at these two. The two that are over here, now you have to ignore the positive or negative sign. The two that are over here, the number that's here, the 2 on both these graphs go to the right, and this number is bigger than 1. When b is greater than 1, when it's anything above 1, guys, not positive or negative, just looking at the number, if it's greater than 1, it is going to go to the right. And think about it, guys, where do the numbers get bigger on the graph? On the right side of the graph, right? Where do the numbers get smaller? To the left. And so when b is less than 1, it's going to go to the left. Look at these over here. See these over here? They have 1/2. 1/2 is a smaller number. These both go to the left. They go up or down, but they still go to the left, go to the left. Now, they make sense, guys. Positive goes up. Negative goes down. Bigger numbers go to the right. Smaller numbers go to the left. It's just like every other graph we've done, but they look different because they're not straight lines. Questions just on the basic concept of the formula. You need to understand this is what it looks like. We'll get more into this as we graph, but those are the rules, just so when you see them, you know what they are. Okay. Good so far? Anybody still writing? Okay, here we go. So, from here, your goal is to decide, is this rule linear or exponential? We're going to tell you how you can recognize it in a chart. We should know for a chart already, for a table already, for linear, but let's take a look. Look right here. On this side, how much is it changing on this side every time? It's going up 1 every time on this side. What is it doing on this side every time?
2.
What by 2? It's not adding 2 every time. It's actually multiplying by 2, which is different than what we've ever done before. Now we're looking at a constant change that is not adding, not adding something every time. It's actually multiplying by the same thing every time. And when you multiply by the same thing every time, it's going to be, I can't get that E. That did not look like an E. Exponential is correct. It's going to be exponential. Now, personally, I would put a little note so that you can remember this. Anytime you multiply by the same number, it's going to be exponential. If you multiply by the same number every time, it's going to be exponential. Okay, looking at the next one, you're going to increase by what every time on these? It has to be consistent for you to find out the rule, guys. On the left side, it's got to be the same. What happens to decide it is what goes over here on the right. What's happening on the right every time over here? You're adding 3 every time? Oh, it is. Yes, adding 3 every time. And if you add the same thing, guys, that's called a constant rate of change. What's the other word for constant rate of change? Huh? No. It is a linear function, but what's it called when you have a constant rate of change? What is the word rate of change the same thing as? Slope. Someone said it. Slope. Thank you. Whoever said that. Who? Thank you. Slope. This is huge, y'all. Listen, write it down. Rates of change, because they're going to use that. They say that on the EOC all the time, and people don't know. They're like, I don't know what is rate of change. Yes, you do. Rate of change is equal to slope. That is the same thing as slope. The slope here would be 3 over 1, which is 3. It's a constant rate of change. You're adding the same thing every time, and that makes it linear. Again, if you want to put a little note down here, this might help you when you get ready to study for this stuff, because you might want to study for this test. You're going to add by the same number. Add, this by is weird, but add by the same number. You're adding the same thing every time. Guys, so listen, if you multiply every time by the same thing, it's exponential. If you add the same thing every time, it is linear. There you go. Now look at these equations. These should be very easy to identify. Is this one, example 3, linear or exponential? It's linear. How do you know it's linear? Both those things are correct. Guys, it's got addition. Y equals mx plus b. It has a slope, it has a y-intercept. Alright? And it does not have multiplication or an exponent. So it can't be exponential. This one would, bless you, this one would be what? Exponential. How can you tell it's exponential? Go ahead. It's a multiplication and what? And it has an exponent. Guys, it's multiplication and it has an exponent. Pretty straightforward. Questions, concerns, anything that you see that you need to ask about? Anything? Okay. So, from here, the next thing we're going to be looking at... Oh, wait. Anybody still writing? Guys, I will wait if you tell me. I just got to make sure. Okay. Here we go. The next thing that you're going to be doing is function notation. You've done this before. It's evaluating when you've got function notation. You know how to do this. It's just substitution. All you're going to do is plug in the 4 wherever there is an x. So we're going to rewrite this as f of 4. All that means is you're plugging in the 4 for the x. And you're going to make it 3 to the 4th power. That's all you do. Plug it in and then work it out on a calculator. Grab your calculators once you write that down. 3 to the 4th gets pretty big quickly.
81.
81. Okay, that's it. You're done. That is worked out. Okay. Remember, this means what, guys? Ooh, what does f of x mean? F of x is the same thing as y. It's just another way to say y equals. That's all it is. What it's saying is when I plug in 4 for my x, I get 81 for my y. So basically it's giving you an ordered pair where you'd know that 4 would be your x and 81 would be your y. They're not asking for that yet. You deal with that later on when you're graphing with this and stuff in Algebra 2, but That's where we're leading to. Okay? So whenever you see there is nothing to work out there, that's just the notation. That's how you write it. That's not something you work out. It's a good question. Anybody else? Okay, let's do it again. H of what? Negative 2. Negative, don't miss the negative, guys. Is going to be 10 times 5 to the negative 2. Now, these are going to be in tables. This is not something where you're going to be using this for something else. So this is going to be in table to the side, greater than whatever it is. You've got to understand that when you're doing these, you're still going to move them, still going to work it out. You just need to get to a number. So you got to start by putting a 1 underneath here. The 10's going to stay on top. The 5's going to move to the bottom. And actually, it'll do it on the calculator if you type it that way. That makes it f of negative 2 equals 10 over, what's 5 squared? 25. Which makes it f of negative 2. Huh? Oh, I don't know why I changed it. Sorry. Y'all, no, thank you, say it. No, not at all. I just started, I was answering that question and then got sidetracked. No, absolutely not. Thank you for saying something. No, that was totally me. Can you tell I do the same thing all day, so I get a little lost in where I'm at? Yeah. Okay, here we go. H of negative 2. Hey, what's it reduced to? 2 over 5. Does anybody have a question? You type in 10 fraction by 25, 10 fraction by 25 reduces it down for you guys. Okay. Questions? Okay, the next thing we do is going to be the same thing, but just with more because you're dealing with tables. Oh, actually, don't we have the word problem first? Yeah. Okay, listen to me. Reading what it says is how you solve a word problem. They actually give you the equation. You just have to figure out what number to plug into it. Let's read this and see if you can see what it tells you. Okay, an investment of $500 in a certain money market account triples in value every 6 years. The function that models that growth is f of x equals 500 times 3 to the x. Write it down. F of x equals 500 times 3 to the x. They've written it out. $500 triples, so times 3, and they want to know how many years, every how many years. You've got to put it up there and put triples every how many years. It says, where x is the number of times that the money will triple. If the investor does not withdraw any money for this account, how much money will be available after 24 years? Now listen to me. 24 is not the number. Okay? 6 is not the number. Okay, your money triples every 6 years. And we're going over 24 years. So how many 6-year periods are in that 24 years? How did you do that? You divided 24 total years, and every 6 years it's going to triple, so it's going to triple a total of 4 times. That's how many times your money will triple. So 4 is the number you plug in for this. F of 4 equals 500 times 3 to the 4th. Okay guys, the reason that happens, 6 years it triples. Okay, after 6 years it triples. After 12 years it does it again. After 18 years it does it a 3rd time, and then after 24 years is the 4th time. It does it every 6 years. So it does it a total of 4 times over that 24 years. Okay guys, f of 4 equals, larger number, what is it? Whoa, I got different answers. What was it? 40,500. 40500. So you could start with, but now y'all, you know that things don't get that big that quick normally in investments. That's a incredible return. That would never happen. But okay, you do make money when you put money in. So if you save $500 and you left it there for 24 years, that's what you would come out with in this investment. So your answer would be $40,000, $40,500. Guys, you're going to have word problems like that. They didn't even ask you to write the formula. All you're doing is plugging into the formula. You just got to figure out what number to plug into it. The only math for that is this, to figure out what number to plug into it. It's different every time. You got to read what it asks you. Yes, ma'am.
So at any time we have a word problem like that, we have to divide it?
It depends on the problem.
Okay.
It's not going to be the same every time. So like one of them says, if the car maker gets paid for every year past like 2017, well, how many years is that since then? 18, 19, 20, 21, 22, 23. So we've got 6 years. It's different every time. It depends on how they word the question. It's not like you do this. Right? Anybody else? Okay. Last thing then is the tables. Guys, listen to me. For the tables, I will take decimals. So you can write on here, decimals are acceptable in the tables. Yeah, I will take decimals because all you're using is the numbers to decide if the domain is, as the domain increases, is the range going to increase or decrease? Now let's remind you, guys, about these words. The word domain goes with the what's? X's. And the word range means we're going with the y's. Guys, another way to say y is f of x, or in this case g of m for the second one. Those are the y's. Okay, so we're setting up tables. The table's going to look like this, and there's a table exactly like this on your test. Just telling you up front. Here's the table. X goes here. What am I putting over here for the x's? Read the problem. Oh, sorry, my thing just, I don't know if it's going to work or not. -1, 0, and 1. Oh, it's still working. It's making ugly faces on me on the little screen. Then it's going to be what we're plugging into, which is this part, which is 2 to the x. And then over here, it's going to be f of x. Guys, that's just another way to write y. So it's just whatever this is goes here at the end. That's your y. X and y, x and y. So when we plug this in, 2 to the -1, 2 to the 0, and 2 to the 1. Make sure you're replacing the exponent is what changes, guys. Not the number, not the base. The base is 2. The exponent is what changes. Again, I'll take decimals in the table because you're going to use it to decide increase or decrease. You're not really using it just to get the numbers. So do 2 power button -1. 2 power button -1. What's that give you as a decimal? 0.5. Okay, don't use a calculator for the next one. What's any number raised to the 0 power? 1. It was actually the best answer on the entire test. People that missed every single other problem on the entire test got that one right. They did. The next one, 2 to the 1? 2. 2 to raise to the first power would just be 2. We don't write the 1 there, we just write 2. Okay, guys, so as this increases, what happens to the range? What does it do? It increases. That's what you're deciding. Does it increase or decrease? Okay, guys, same thing on the last one. The last one today looks like this. You're going to set up your table. And I think you have like 3 of these on your homework. You got to set up the tables yourself, so you're definitely going to need to be able to do this. Over here, you're going to put what letter? There's no X in this problem. M. No X in this problem. M. In here, you're going to put 3 times 0.4 to the M. And then over here, you're going to put your G of M. Start by setting up your table, guys. Oh, and I can't be here after, I'll be here until about, I think we go at 2:40, 2:50. We have a faculty meeting, so I'll be here for like 1 period, but then I'll be gone. I've got to go to the faculty meeting. Okay, what numbers are we plugging in for M? Thank you. Perfect. So when you write this, it's going to be 3 times 0.4 to the negative 1. 3 times 0.4 to the 0. 3 times 0.4 to the 1. Guys, once you get those, it's just calculator work. That's all it is. Type this in on the calculator. Decimals are acceptable, so you're just going to type it straight across. All we're doing is using these numbers to determine whether it's going to go up, down, whatever it is. I will accept decimals for this. So, what's 3 times 0.4 to the negative 1 power?
0.75.
Point what?
0.75.
Now I got 7.5, I think. Was it 7.5 or point? Try typing it again. See if you got the decimal wrong. 7.5. So try typing it. 3 times 0.4 power button negative 1 equals. I thought so. I just want to make sure. Because it sounds like all you did was left out a decimal or put one more, like 0.04 instead or something. Okay, do it again. Guys, you don't even need to do it on the next one. What's anything raised to the 0 power? And 3 times 1 would be? 3. No work there. And then 3 times 0.4 to the first power? 1.2. So as it goes from here to here, what does it do? Decreases. That's not decreases. Let's try that again. Decreases. There we go. Okay, guys, that's your notes for today. We're going to apply that to the worksheet and get you going. So from here,